Hello, everyone. Good afternoon and good morning, depends on where you're dialing from. And thanks for joining another Megaport Live Tech Drop-in session. So let's start with what is this all about? And Megaport, we host three sessions globally every Friday, um, basically led by the solution architect team from APAC, North American, and Europe. And this is a informal chat pretty much about our products and solutions. So please feel free to bring up any questions or hot topics you want us to discuss or want us to touch on. We also aim to do some live demos at the end of the session and show you how Megaport services actually work in the real world if you haven't got a chance to try yourself. Here is a little bit about myself. My name is Morgan Wang, and I'm a solution architect based in Melbourne. I support our customers in Victoria, Tasmania, and New Zealand. If you have any requirements or questions, please feel free to reach out. You can contact me via email or connect me on LinkedIn using the details below. I'll probably post that for 5 seconds. So if you need to take any notes. Okay, we do have a topic today for this session. I'll be continuing our Global WAN discussion from 14th of February, the Valentine's Day session. If you missed last session, don't worry. All the tech drop-in sessions are recorded, including this one, and they are available on the Megaport Solution Architect YouTube channel. So feel free to check them out. I really hope I can have like a YouTuber's this a hyperlink here that you can click and check the channel, but it's very easy to find on YouTube. I'll be also doing some simple demos today, followed by a Q&A session at the end if you have anything you want to bring up. But before that, let's still briefly talk about who is the Megaport and what Megaport does. So Megaport is probably the largest network as a service provider globally. And at the moment, we are in over 930 data centers globally. So that means you can order Megaport service from pretty much all over the world. And we are interconnected to public cloud providers and other partners on the Megaport platform and over 280 on-ramp locations. And from these locations and data centers, you can actually bring the traffic or bring the connectivity back to your data center or to your head office, as long as we do have footprint in your particular location. In terms of products, um, our products are pretty straightforward. On the left side of this picture, you have three access products, which you can use to get access to Megaport network. The first one is a physical port in the data center. That's where Megaport started with. Pretty much you order a port from Megaport. That's our demarcation point, and run the cross connection to your rack. And from there, you physically connect into a Megaport network. Otherwise, if you don't own a data center, or unfortunately, Megaport is not yet in your data center, you can actually leverage our Megaport Cloud Router or Megaport Virtual Edge to interconnect multiple cloud services you have, or otherwise use a MV as a edge device to connect your existing network into Megaport network. And from these three access services, what you need to do is actually just order VXC virtual cross connection to connect into Megaport ecosystem. And they are simple layer 2 virtual connections, and they also private, not VPN over internet. As I mentioned, the Megaport probably started with a physical port in the data center, and The connectivity module of physical ports in data center pretty much about connecting your data center A to your data center B with a VXC, or connecting your data center to a public cloud provider, for example, AWS, Azure, or Google Cloud. Or otherwise, if you do need internet service, Megaport now provide internet service in certain metro areas. You can actually order a Megaport internet service as a VLAN and inject into your physical port in the data center. The last one probably use leverage Megaport's global backbone network to interconnect your data centers globally. That's pretty fundamental of today's topic, global WAN. But if you don't have a data center or not yet have the data center enabled by Megaport, you can still leverage the Megaport services. For example, there's 4 scenarios here. The first one, probably if you are cloud native enterprise or business, and you can leverage MCR or MV to interconnect your multiple public cloud services. Or otherwise, if you do have a multi-cloud tenancies and or even third-party services provided through Megaport ecosystem or marketplace, you can still use MCR and MV to interconnect those services and also backhauling the services back to your data center. The third one here, down the left bottom, is in addition to that, actually turn MV to an internet gateway is also another option. So we'll provide internet connectivity to your data center or even to your public cloud tenancy. The last one is if you don't have a data center, unfortunately, or the data center is not currently enabled with Megaport, you can still use MVE to build an edge gateway over the internet. So you can use that either a more static way as a firewall plus IPsec VPN tunnels to connect your data center or offices into Megaport Fabric, or it can be a more dynamic SD-WAN edge device to join with your existing SD-WAN overlay network, which will allow your office or DCs to connect to cloud service through the Megaport. With the last one, with edge device, there probably in this diagram you probably see a probably more advanced setup, which separate the edge device with your security device, which both of them actually on the Megaport MV platform. You turn one MV appliance to a SD-WAN edge, another one probably to your security device, can be a next generation firewall, things like that. So it will help with a very clear role definition of every single MVE. So this one is for edge, that one is for security, and also for a better performance estimation and measurement as well. Last one, probably not least one for today, is a global one. Apparently, that's today's main topic. When you need to build the connectivity to multiple data centers or multiple cloud services, or even with different partners on the Megaport marketplace, especially if you have a global distribution, globally distributed, and that's where the concept of global WAN kicks in. So with multiple POPs built onto Megaport platform, you can join all the services and all the endpoints together with Megaport Fabric. So this example here is actually more specific about SD-WAN, Global WAN as a service. And this is one of the simple setup. The reason being, this is an enterprise that has a global presence, but they only use Azure cloud, for example, single public cloud strategy in place. So you can see globally, all the data centers and MCRs are connecting to Azure only. They do have regional data center setups. That means in American in Singapore, in Europe, they have a data center, so they have physical ports enabled to connect or backhauling the traffic to the data center. Yeah, but still, with Megaport, the multiple regions can connect together through the Megaport backhaul. And today we probably do something a little bit different to that and a little bit similar as well. Let me bring on the diagram. This is, as mentioned, this is a continue of our topic back in 14th of February, where in that session I was trying to build a global WAN network, but unfortunately there are too many elements and I couldn't have all of them finished. But this is the setup or the baseline of this demo. You can see the green ones are actually established. The concept is I have a headquarter here in Melbourne, where I'm located, and I have my edge device or internet gateway provisioned in Melbourne for the breakout. I also have my MCR provisioned in Melbourne to interconnect to Google Cloud. And the business is apparently growing, and I have another regional office set up in Singapore, and I have acquired Singapore AWS from Singapore region. So I have another MCR provisioned in Singapore and interconnected to my Singapore region AWS. So that's pretty much the start point. And based on that, I'll probably build the whole global WAN service within hopefully a couple minutes or maybe 10 minutes. I have the portal here. You can see that mapping the initial setup. Here is my internet edge device in Melbourne, which is our partner 6Wind router. And I have an internet service provision to the router. I have a VXC cross connect from the router to my Melbourne MCR. And from Melbourne MCR, I have two connections apparently onward. One is towards my Google Cloud, another one is to my Singapore MCR router. And from the Singapore router, then I have access to AWS. So let's take a look at the Singapore router. We do have a looking glass function built in with the MCR device. The video probably takes too much of my bandwidth. Okay, let's take another look at the Singapore router, right? Yeah, from the looking glass, I can see I'm pairing with my AWS and also I'm pairing with my MCR in Melbourne. I should have a route table here. And from the route table, I can see the path from Melbourne and my internet gateway for my default. And there are two routes from AWS directly. One route from AWS directly and two routes from Google Cloud through Melbourne MCR. So that's pretty much my initial setup. And because last time I couldn't finish all the demo because there are too many elements and too many services. So this week I came up with a better idea. I'll probably just use Terraform, which is infrastructure as code that's supported by Megaport, that you can write your code as your infrastructure and just automatically provision everything to the Megaport portal. So have a quick look at the my Terraform codes. That's all my locations. And you notice that I have my Melbourne router and my Singapore router highlighted. That's my current setup. All the others are grayed out. I have my MVE Melbourne enabled and the full VNIC provisioned for that MVE, and I have my internet service plugged into my MVE. Other than that, I do have a Melbourne MCR interconnect to Melbourne MVE and another Melbourne MCR connect to Singapore. So this is my command line of the Melbourne MVE. So wait for, you can see now from the MVE, which is a router, aka my internet gateway, I receive the default route from my internet. I receive the AWS and I receive the Google Cloud routes as well. So what I'm trying to do now is I'll decomment all the grayed out services. Basically, from here, you can see I'll provision a MCR in New York, MCR in London, MCR in Tokyo. That's all my MCR setups. And after that, I'll also need to provision VXC between Singapore and New York. Another one, New York to London, New York to Tokyo, London to Singapore, and Tokyo back to Melbourne. So that's my whole global protected connection. With that, jump into my Terraform just to try to plan and see what that change involves. Terraform let me know that I need to add two services based on my current setup and my destination. So I'm happy with that. Let me just apply that. Terraform validates my configuration again and ask me to confirm. Yes, go ahead with creating resources. Yeah, we might come back to Terraform later, but before that, you notice in the diagram, I still have two other services. One is a port in Silicon Valley, another is port in Japan. That's in my setup, my regional data centers, my regional physical data centers. So while the Terraform is doing all the MCR and the interconnections between the MCRs, I might just manually create two ports in those data centers for my physical tendencies. One is to Santa Clara. That's a Silicon Valley one. Like a 10 gig port for that. Santa Clara. The port is in my configuration. I'll go ahead and create another port in Tokyo. That's the first one. Another 10 gig port. Review the order and click order. As all the other services, the port should be come up within 60 seconds, and I should be able to receive a letter of authorization for the cross connection works. I can then send back to the data center operator to organize my cross connection. While we're waiting for that, let's have a look at how is Terraform going with creating the MCRs. The working now is 1 minute roughly. You go refresh, see if there is any service up already. Okay, see now I have my Tokyo router up and I have my London router up, New York router up. So while we're waiting for the VXCs between all the routers, interconnect all the routers, I might just go ahead create a VXC between my new port and my new router. That's private VXC. and I'll connect to the Tokyo MCR. You notice that all the services sequenced by latency. So I connect that to my close service. MCR to port. Use 1 gig now. Yeah, this is a layer 2 service. So not all the information are mandated. So you can input all the peering IP address information for the MCR later on. Or otherwise, you already have a plan how you want to interconnect those services on layer 3, then you can have your IP address directly input here. And once you then plug your router into the data center port, your router will be establishing the BGP session with the MCR. I'll just skip that because I don't have that design ready yet. And I'll create another private VXC from my Silicon Valley to my New York MCR. Port to New York MCR. Okay. Still, I don't have the IP addressing yet. I'll go ahead and just provision the VXC. Let's refresh and have a look. How did it go with MCR VXC creation? Seems still working, but let's try to go into one of the MCR, which is New York MCR, and have a look if the BGP session is up. Oh, not yet. Still creating. The router itself is up, but the BGP session still needs some more time. I'm probably pushing too many services all together at the same time. Apparently, more routes available. That means actually some sessions already up. Go back to the portal, refresh, and come back again. Yeah, I got one up from London to Singapore. Hopefully, New York probably too busy, and too many VXCs. Let's have a look at London instead. Okay, now I have London, which I'm peering Singapore and New York based on the S number 001 and 002. Back to my diagram, London is here. I'm peering with 002 and 001. It's good. And I have received so many routes. Apparently, what I'm really care about now is my AWS route and my Google Cloud route. And go back to the BGP table, you can see I have actually two default routes, which supposed to be in Melbourne. The first one is a preferred one that's through Singapore and Melbourne and to my internet gateway. Another one is through New York, 002 and 004. I think that's Tokyo. Yeah, that's Tokyo. And back to Melbourne and to my gateway. So that's pretty much London is fully connected and has multiple paths to AWS, to let's have a look. Oh, AWS just one path, yeah. AWS just one path. Oh, sorry. Yeah, AWS is one path, and Google I have two paths now, Singapore and Melbourne, and this one is New York, Tokyo, Melbourne, and Google Cloud. All right, let's go ahead and have a look of New York. This is the busiest one with my setup. So many connections. I have a 001, that's a Singapore. 003, that's London, and 004, that's my Tokyo. And I do have another connection to my port in Silicon Valley, but apparently I didn't provide any layer 3 information, and there's no router connected, so there's nothing here, there's no peering. Back to the BGP table, I have three different default routes through Tokyo, through Singapore, and through London. And I have three different AWS routes. So you can see that if my preferred one, Tokyo, goes down, I still have two paths available to access my internet. And if Singapore goes down, I still have two paths. Technically, I still have two paths to access AWS. Um, and I have three paths to Google Cloud as well. So yeah, that's pretty much the demo I want to show you guys today about how to create a global WAN with Megaport fabric within. I think we did that in 10 minutes, and yeah, that's pretty much the very simplified scenario where a customer have two public cloud services and the multiple regional data centers and the multiple regional prisons. So you can see that I have connected them all together. I might just pause here, see if there is any questions about uh, the demo or the product itself. Uh, yeah, just right. You're right. I do have only one single pass to AWS because if this Singapore goes down, actually all the two other paths will go down as well because Singapore actually is a single point of failure for my AWS connection. And um, great call out, by the way. What you can do is actually with different public cloud providers, they have different strategies. For example, with Azure, you can do maximum redundancy setup, or you can do standard but pairing with two MSEEs in one location. With Google Cloud, you can do protected WLAN attachments instead of single WLAN attachment. And with AWS, you can create two direct connections to the AWS same region. You can within the same region, you can have multiple locations to pick from. For example, I'm in Melbourne. I can connect into Asia Pacific Southeast 2 from Melbourne, from Sydney, from Auckland, or from Perth. That actually provided me a very good option to design my high availability setup. And when you have multiple connections to the public cloud data center, to the public cloud services, you can actually connect them back to a diverse pair of MCRs so that you don't have a single point of failure on the Megaport platform as well. For example, in this case, I might have two cloud routers in Singapore, both sitting in the AS number 001. And I can also interconnect them together, and I can connect them to separate cloud routers in different regions. So in case my Singapore MCR1 goes down, I still have my Singapore MCR2 up and running, and the BGP will fail over from 1 to 2. And in that case, I will still have my access to AWS, not like this one, 100% single point of failure. Yeah, that's just for demo, but in the real world, you can 100% do a better protection in terms of accessing the public cloud providers. Yeah, I hope that you found the session helpful with building up a global WAN service with Megaport, and the time is up. And thank you very much for joining the session, and probably see you guys next week. Bye. Thank you.